Okay. So, anything that you want to review? I don't know. Have any of you looked at the homework questions yet? Maybe we can look at some of those. Obviously, we're not going to write down every step in the homework problems, but at least kind of look at some of the questions that will help you. And I still don't know exactly what's going to be on the exam, so I'm assuming it's going to be the undetermined coefficients, which is sometimes called judicious guessing. That will be definitely on the exam. We're also going to assume that variation of parameters will be on it. So whatever is in the homework 4 worksheet, that could be on the exam.
The question?
Uh-huh.
I just have a question here.
Oh.
The second part is trying to find the y equation.
Yep.
So the one I chose with the way that I'm solving it, it doesn't seem like it's going to work out.
Okay. Let me write down the question, then we can look at that. So number 3 in the homework, so we solve y double prime plus y prime minus 6y equals sine t plus e to the 2t. And then assuming that you already found the homogeneous solution, which is going to be c1 e to the negative 3t plus c2 e to the 2t. Excellent. Good. That's good. And then, so this is this problem asks you to use judicious guessing, the undetermined coefficients. The right-hand side, the f of x, we have it's a sum of two functions, the sine function and the exponential function, right? So let's just treat them separately. Let's just see we don't have the e to the 2t. If we just have sine t there, and then the guess will be the particular solution we can guess to be maybe a cosine t plus b sine t, right? That's if you just have a sine, that's what we're going to guess. Or if we have a cosine function, we're going to guess the particular solution to be like that. And then what about if we have e to the 2t? Well, if we just have e to the 2t, normally we will guess the particular solution to be a different e to the 2t, right? That's what the guess will be. But so the guess will be so the guess for particular solution will be a cosine t plus b sine t, and maybe plus c e to the 2t if we were to follow this the function f of x, because that's the sum of two functions, so the particular solution should be the sum of those two guesses. But the problem here is that for this e to the 2t term, that already shows up in the homogeneous solution. So if you look at the homogeneous solution, we already have the e to the 2t. So this part in the particular solution, we wouldn't be able to find anything because that term, if we guess like e to the 2t, it will be absorbed in here. So we wouldn't be able to figure out what the constant for e to the 2t is because we don't know. It's just some constant c2. So that's not a good guess. So we have to replace this guess by multiply by x, but only to this term. In this case, multiply by t. So instead of using c e to the 2t, we're going to use c times t times e to the 2t. And now this is different from the terms in the homogeneous solution. So every time the particular solution you guess shows up in the homogeneous solution, you're just going to multiply by t or multiply by x until they're different. That's a good question. I think number two, if you were to follow this approach, eventually when you guess a particular solution, it shows up in the homogeneous solution, so you have to multiply by x in number 2. And from here, we're going to have to find the derivative of this particular solution. and then find the second derivative of this particular solution, and I'm going to let you do the work. And after that, we have also three expressions we can put into the given differential equation in the beginning. The y double prime plus y prime minus 6y. Okay. Excellent. Good. Any other questions? So that's using the judicious guessing. It's you guess what the particular solution is based on the f of x function, and then you put it back into the differential equation, solve for a, b, c. So eventually we're going to find a. If you want, I can just write down what a is. That way you can check your work. A ends up to be negative 1 over 50. B, double check A cosine B. B ends up to be negative 7 over 50. And C is 1 over 5. And then you can write down the particular solution, the general solution from there. Questions? Number 4 is similar. So number 4 in the homework, we're going to solve 2y double prime minus 3y prime plus y equals t squared plus 1 e to the 2t. So the first thing to find the homogeneous solution is going to be c1 e to the 1/2 t plus c2 e to the t. Again, you have to show the work. Well, when you submit the homework, make sure you show the work to get the homogeneous solution. And then we have to guess the particular solution based on the function f of x, which is this part. And f of x is the product of two functions, right? One is if we cover e to the 2t, so we get t squared plus 1. That's just like the x squared plus 1 is a quadratic function. We can get the particular solution to be at squared plus bt plus c. Even if we don't have the t term in the parentheses, we can get a particular solution, we have to include that term. So we need all three terms in the quadratic expression. And the e to the 2t, if we just have that, we don't have the t squared plus 1 term. If we only have e to the 2t, then we can guess the particular solution to be some constant a. In this case, I'm going to call it d e to the 2t. And then now it's good to do a quick check. So that's the e to the 2t. It doesn't match any terms in the homogeneous solution, so that's totally okay to use. Therefore, the particular solution is going to be at squared plus bt plus c times d e to the 2t. It might look like we have 4 different constants, right? A, B, C, D. But if we simplify this by distributing d into the parentheses, we get ad t squared plus bd times t plus cd times e to the 2t. AB here is just, A is a constant, B is a constant, so A times B is just a constant, we don't know. BD is also one constant, CD is one constant, so we can actually rename them. So maybe we can call this, I don't know, you can use a different letter. Maybe call this A hat or A1 t squared plus B hat t plus C hat. e to the 2t. So in the end, we will only be able to find 3 constants, not 4. And then the process is the same. We find the derivative, and then we find the second derivative of this particular solution. We take them, put into the given differential equation. We should be able to combine like terms there, and then end up finding a hat, b hat, and c hat. Any questions on that process? I know it's easier for me to kind of just point out what you should be doing, but when you actually solve the problem, make sure you know what you're doing in the process. So just for you to check your work, at the end, the a hat is 1 over 3, b hat is negative 10 over 9, c hat is going to be 47 over 27. And obviously we need to write down the particular solution and the general solution after that. Questions? I definitely think the homework problems are good practice. If you were to try to get some practice for the exam. Any other questions that we should look at from number 1 to 4, or even 5 to 8?
Yeah, can you do the second half of 6?
Number 6?
Yeah.
Yep. Absolutely. So, yep. So 5 to 8, you have to use, well, the instruction asks you to use variation of parameters. So, number 6. So we're going to solve y double prime plus y equals secant t. And the t here given a interval from negative pi over 2 to pi over 2. We don't need it for a while, but just keep that in mind. So if we were to find the homogeneous solution, and I'm going to let you do some of the work. So eventually you solve for the characteristic equation, the lambda, y equal to plus minus I. It's a complex, so that means you have the choice to use sine and a cosine. It turns out that the two base solutions, it's going to be y1 is cosine t, y2 is sine t. Because we just have plus minus I, so the constant in terms of in front of I is just 1. So it's just going to be t. If you have plus minus 2i, so that's going to be cosine 2t sine 2. So the homogeneous solution is going to be c1 cosine t plus c2 sine t. And next we need to find the particular solution using variation of parameters. I'm going to show you the way I did last time by using the system of equations, and after that I'm going to show you what Professor Gibson did by using the determinants and the matrices. At the end you can decide which one to use. I think you can choose. Personally, I'm fine with either approach. Sometimes, for some example, the matrices, the determinants will save a lot of time, but sometimes the system of equations method will be more straightforward. So Well, we all begin with this general form of particular solution, which is u1 y1 minus, plus u2 y2. So that's the general form of the particular solution. And if we need the system of equations, we should begin with two equations, u1 prime times y1 plus u2 prime times y2 must equal to 0. u1 prime times y1 prime plus u2 prime times y2 prime must equal to f of x. So if you were to use system of equations, make sure that you get those two equations correct to begin with. Because those two equations will allow us to find u1 prime and u2 prime. So I'm going to plug in what we have. So that's going to be u1 prime times y1 cosine t plus u2 prime times y2 sine t equals 0. And then the second equation gives me u1 prime times y1 prime, so we have to take the derivative of cosine, which is negative sine, plus u2 prime times the derivative of sine, which is just cosine, equals f of x. Sorry, f of x is secant t. And now we should try to solve this. Obviously, we can just directly add or subtract to cancel terms to eliminate any of the variables. Because here we have u1 prime times cosine, but then here we have u1 prime times negative sine, so they're not the same. Same thing with the u2 prime terms, one has a cosine, one has a sine. So what we could do in this case, usually what we do is that we take one equation, we multiply by cosine or sine. We take the other equation, multiply by the other one, the other three functions. It really doesn't matter which one you try to eliminate. If we try to get rid of u1 prime, we need to make sure that this is sine and cosine, this one is sine and cosine. If we try to get rid of u2 prime, we want to multiply this equation by cosine so that we can get rid of the u2 prime here. So it really depends. Because we have the secant here, secant is 1 over cosine in the second equation. So I'm going to take the second equation and multiply by cosine. Take the first equation, multiply by sine. The benefit of this is that secant times cosine becomes 1, so we have 1 to work with, and we still have a 0 here. So that will give me, the first equation is u1 prime cosine t sine t plus u2 prime sine t, so that's a sine squared t, equals 0. And the second equation gave me negative u1 prime sine t cosine t. It might seem like we have a lot of writing here, but the next step, a lot of terms, two terms cancel when we add them. So it's really not that bad. u2 prime times cosine t, that's a cosine squared t, equals secant t times cosine t is 1. So now we can eliminate because at least for the u1 prime, we have cosine sine attached to it. So that means that those two terms are basically the same except for the sine. Positive, negative, when we add them, this gives me 0. When we add this, it's not that bad because we have sine squared plus cosine squared. So take the equation 1 and the 2, add them together. So we get 0 from the first terms, and then we get u2 prime sine squared t plus cosine squared t equals 1. And if you remember the trig identity, that's also 1, right? So really this u2 prime equals 1. And now we can take u2 prime and then go back to the equations. I would say maybe using this one before we multiply by sign. So we're just going to plug in u2 prime equals 1 there. We can solve for u1 prime. I'm going to let you figure it out. I'm going to do it quickly. So u1 prime equals negative sine over cosine, which is negative tangent. And we have to integrate to figure out u1. So u1 equals integral negative tangent t dt. You might have it memorized, which is useful here if you do have that integral memorized. If you haven't, you can always write this. Let's just say you don't have it memorized. You can write this as negative sine t over cosine t dt, and then use u substitution if you didn't have it memorized. If you have it memorized, it's going to be natural log absolute value cosine t. Or you can just look it up if you, well, I'm not sure that's a good advice, but I did. I looked it up. So from here we have an absolute value. This is where the condition given earlier was t. So if you remember that earlier we had t is from negative pi over 2 to positive pi over 2. On a unit circle, that means it's going to be from negative pi over 2 to positive pi over 2. It's going to cover the right half of the circle without including the axis in the middle, the y-axis. So that means for any angle here, the cosine t is always going to be positive, because it's going to give you values. Oops. Not including that, but it's everything there. So cosine t is positive in this interval. We can just drop the absolute value. That's what the condition is for. And I'm going to let you find out u2, which it shouldn't take too long. And then you can figure out the particular solution, because we have u1, then we have u2, we also have y1, y2 from the very beginning. And don't forget to write down the general solution. Any questions about this approach? It's about solving system of equations. There's nothing, nothing too fancy. It's just that when we solve the system of equations, there's a lot of terms and expressions in there that we kind of have to tell us that we're looking for u1 prime and u2 prime all the time. So when we have cosine t, sine t, just treat those as constants. So another way, the way that Professor Gibson does to find the u1 prime and u2 prime, is using matrices and the determinants. So starting from the top, the yp, and from there, the first thing we're going to do is that we're going to find this Wronskian matrix, Wronskian term, called W. So W is defined as the determinant of this matrix, which is really the coefficient matrix of the system of equations. So if we just look at this two equations I had, u1 prime is a variable, so that means y1 is a coefficient, and the u2 prime is a variable, y2 is a coefficient. and then y1 prime, y2 prime, those are also coefficients. If we put them, take the full parts and put them in a matrix, we get the Wronskian. So y1, y2, y1 prime, y2 prime. So that's what the Wronskian is the determinant of this matrix. If you want to take this approach, you have to memorize what it is. Don't get confused. So have this memorized. So in this example, we can find the Wronskian. So W equals y1, which is we had is cosine t, y2 we have is sine t, and then we can find the derivatives of each. So that's a negative sine t give me cosine t, and then we can find the determinant of this, which is take this diagonal, multiply them, and subtract the product from this diagonal. So that's going to be cosine t is going to be cosine squared t, minus, it's always subtraction, comes from this diagonal, that's going to be sine t times a negative sine t, so that's a negative sine squared t. And it's nice because we have cosine squared plus sine squared, which is 1. It's a good thing that we have something simple. So that's the first thing you need to find, the Wronskian. And the next thing we can do is we can actually write down the formula to finding U1 prime, which is 1 over Wronskian times the determinant of this new matrix. And this new matrix is similar to the Wronskian we had above, except that when we find the U1 prime, the first column here, y1 prime will be replaced by 0 f of x. So that's going to be 0 f of x. But the second column, this part is going to stay y2 prime. So in our example here, I'm just going to plug in what we have. So u1 prime is going to equal to 1 over 1. That's very nice. Times the determinant of 0, f of x is secant t, and the y2 is going to be sine t, the derivative is cosine t. And if we take the determinant of this matrix and then multiply with 1, it's just going to be 0 times cosine t, that's a 0, minus sine t secant t. So 1 times 0 minus sine t secant t. And it turns out that obviously we don't have to write the 1. This is 0 we can ignore. We just have a negative sine t secant t, which is negative tangent t, because secant is 1 over cosine. So you get negative sine over cosine. So it's the same. So if you look back and compare the process, you might find that this method using the determinants and the matrices is actually, well, I guess you could say it's faster. But make sure you have the Wronskian remembered, make sure you have this form remembered. And then we can apply the same thing to find U2 prime, which is 1 over W. When the formula for that, in this matrix, the first column is the same thing as the Wronskian, but the second column will be 0 f of x. So we get y1 prime. And then from there you can plug in what we have and carry out the process. So either approach, as long as you kind of get the correct setup, and eventually take you to the right place, and then still you have to integrate after you find the u1 prime, u2 prime. Questions? So I'm not going to finish it, I'm just going to leave it the way it is and then let you use whichever approach you prefer when you solve those problems. Yeah. That's number 6. Number 7, I think. Similar. Maybe the integration is taking a little bit longer. You have to use integration by parts there. But I think you'll be okay. Number 8, can look at it. So maybe I'll take number 8 and then try to follow this matrices and the determinants method, if it helps. But any questions before we move on to the next homework problem? No. All right, number 8. So we're going to solve 3y double prime plus 4y prime plus y equals e to the negative t sine t. And then in this problem, it'll give you initial conditions. But we're just going to leave it because we don't need it until very late, until the end actually, after we find the general solution. So the first thing we're going to find the homogeneous solution. We're just going to take the homogeneous equation. Finding the homogeneous solution is going to be C1 e to the negative 1 over 3t plus C2 e to the negative t. This is going to be y1. This is going to be y2. And the next step is we're going to find the particular solution, and it will be in the form of u1 y1 plus u2 y2. Now, there's one thing that we haven't really touched on, but Professor Gibson definitely mentioned this in lectures, is that when you have a differential equation that beginning with something, the coefficient of y double prime is not 1, you have to make sure that's a 1 first. So here we have a 3. When we want to find the particular solution, we have to make sure that's a 1 to begin with. So we're going to divide the whole differential equation by 3. So that will be y double prime plus 4 over 3y prime plus 1 over 3y equals 1 over 3 e to the negative t sine t. So this is we only have to do this if we use variation on parameters. If we use undetermined coefficients, we don't have to do any. We don't have to divide by 3. Because what happened here is that the 3 in front of the y double prime is going to affect the f of x later on when we use them to find u1 prime and a u2 prime. So I'm going to use the method Professor Gibson does. So the first thing we're going to find the Wronskian. W is equal to y1, y2, y1 prime, y2 prime. And that's going to plug in the y1 is e to the negative 1/3 t, y2 is e to the minus t, taking the derivative, of each term, so that's a negative 1 over 3 e to the negative 1 over 3t, negative e to the negative t. And then we're going to multiply the diagonals and subtract. So that's going to give us the first diagonal is going to give us negative e to the negative 1 over 3t times e to the negative t. I already bring the negative in front when I multiply that. And then we're going to subtract the product from the other diagonal. So we're going to minus this diagonal, which is going to be, so what we subtract is there's a negative here, the negative 1 over 3 times this product of those two exponential expressions. So that's a minus 1 over 3 e to the negative 1 over 3t e to the minus t. And we can simplify this because this is the e to the negative 1/3 minus 1 negative 4 over 3t. Same thing here, but the coefficients are slightly different. We have negative e to the negative 4 over 3t plus 1 over 3 e to the negative 4 over 3t. We can combine further, that becomes a negative 2 over 3 e to the negative 4 over 3t. So double check, make sure everything's right there. And then we can find the u1 prime from here, which is 1 over w times this determinant. And then the matrix is going to be, if you remember, it's just going to be 0 f of x, y2 prime, so now we can plug in the Wronskian, so that's a 1 over negative 2 over 3 e to the negative 4 over 3t. And then the matrix, be careful there, it's a 0 and the f of x. So f of x here is not the original, it's not the original f of x we were given at the beginning, because now we're working with this. This is the differential equation we work with to find a particular solution. So f of x is coming from the right-hand side there, which is 1/3. So this is what we call the f of x now, which is 1 over 3 e to the minus t sine t. Which is, if you, let's just say you happen to be, kind of going back to the original differential equation, pick the right-hand side to be f of x. It's not the end of the world. The only difference is that you're missing a 1/3. So for the final answer, probably just apply a constant. And the y2 is e to the negative t, and the negative e to the negative t. So from here, we have to find the determinant again. But be very careful because we have a lot of fractions, we have a lot of exponents, a lot of negatives. So just be careful. So 1 over negative is negative, 1 over 2 over 3 is 3 over 2, 1 over e to the negative is e to the positive exponent. So that's a negative 3 over 2 e to the positive 4 over 3t. So that's just the 1 over w part. And from here we have to calculate the determinant. So that's a 0 times this, that's a 0, right? and then minus this diagonal. So 0 minus e to the negative t times 1 over 3 times e to the negative t sine t. Which we can simplify the 0, we don't have to write it, this negative, and then this negative becomes positive. 3 over 2, 1 over 3, we can group them, becomes 1/2. So, what I meant is that this negative, this positive, become negative, negative become positive. 3/2 and the 1/3 can be grouped together, become 1/2. So we got 1/2 e to the 4 over 3t, and then e to the minus t, e to the minus, negative t, and then sine t. Those three exponential terms, we can combine them by adding the exponents together. And it turns out that's going to be 1/2 e to the negative 2 over 3t sine t, I believe. And I'm going to let you find u2 prime on your own. Probably similar. And then we have to find the u1 by integrating 1/2 e to the negative 2 over 3t sine t dt. I have a question for you. How will you integrate this? By parts. Integration by parts, right? Because u substitution clearly doesn't work. There's no concept u substitution will work. You have two functions, one is exponential, one is sine. So when you use integration by parts, and I'm sure you've seen this multiple times in the past, you probably don't remember. So what happens is that when you use integration by parts, the first part, when you use, it depends, well, doesn't matter what you call it, it's the u, the v, you're going to end up with exponential sine, exponential cosine, I think. But then you have an integral with exponential cosine t dt. Then you have to use integration by parts again. So, okay, I'm not writing down so be careful here. I'm not writing down the coefficient, so there should be some constants in front of it. I'm just not writing it at all. So we have e to the negative 2 over 3t sine. If I integrate sine, I get cosine, negative cosine. So your integration by parts again, so this will give us e to the negative 2 over 3t sine t, and then minus the integral of, oh my goodness, I don't think I'm doing it right, but anyway, uv minus vq. I don't remember, but anyway, you get something like, so basically we want to find this integral with exponential and the sine in there, and then when we use integration by parts, we get two terms, but then we still end up with exponential with sine. So what you do next is you move this integral to the left to combine with this one, and then divide by whatever constant in front of it. Does that sound familiar? So at the end, what happened is that you end up, after your integration by parts twice, you end up with this 1/2 e to the negative 2 over 3t sine t dt on the left side, and then you have this exponential cosine, and then maybe plus or minus exponential sine. Obviously the coefficients, I'm not writing them, but then you have minus, or maybe plus, another integral e to the negative 2 over 3t sine t dt. And this half, you can just move it in front. So what I'm saying is that when you integrate it by part, you still end up with the integral that you try to find. So what you do is that you take this integral, you move it to the left side to combine with this integral, so you end up with one integral, and then there's no integral left. I'm pretty sure you've seen it in the past. It might be a while. So now you're going to take this, group it with this. That way you only have one integral, and then equals something. So this is the answer for the integral. I have 2 minutes. I don't think I have enough time to do it. But maybe, let's see if I have the answer here. Okay, maybe instead of just waving my hands, let me write down what I have. So if we use integration by parts the first time, we end up with, so the half, obviously we can move outside. So we end up with 1/2 negative e to the negative 2 over 3 t cosine t minus 2 over 3 integral e to the negative 3/2 t cosine t dt. So that's all in the bracket. And then if we just look at the integral in the bracket alone, and we try to integrate that part, that's going to give us e to the negative 2 over 3t sine t minus integral, plus integral 2 over 3 e to the negative 3. Okay, well, not too bad. So at the end, if we treat it, so if we take this and this, if we put it into this integral part right here, and then write it as one equation, we end up with 1/2, the one we're looking for, 1/2 e to the negative 2 over 3t sine t dt is equal to 1/2 times negative e to the negative 2/3 t cosine t minus 2 over 3 e to the negative 2 over 3t sine t plus, sorry, I'm just kind of still waving my hands. So that's what we have. And then what we do is we distribute the 1/2, distribute the negative 2 over 3, and then take this integral, move it to the left, and combine with that integral. We should be able to find what that integral is. Sorry, I'm going to let you finish it. I think you'll be okay. Obviously, you're not going to have anything like this problem on the exam because it's going to take forever, right? But the process, it's the same. It's just try to understand the process and you'll be good. All right, good luck, and I'll see you next